Hey everybody, today's lesson from Unit 2.1, notes number 8, is all about the midsegment of a triangle. A midsegment of a triangle is a segment that connects the midpoints of two sides of the triangle. So in the triangle that we see here, if we're given information that point M on this side of the triangle is a midpoint, we can say that those two segments are congruent. And let's say point N is a midpoint of this side of the triangle. Then line segment MN is what's called a midsegment. Now every triangle actually has three midsegments. So imagine if we come down here and we put point P as the midpoint of this third side of the triangle. Then point P could be connected to M, and point P could also be connected to N. So MP, line segment MP, and line segment PN are also midsegments. We have a really quick theorem about the midsegment of a triangle, and that is the midsegment theorem. The segment connecting the midpoints of two sides of a triangle is parallel to the third side and is half as long as that side. So in our triangle here, let's draw in two midpoints. Let's call it point D on the left side, and let's call this point E on that right side. Show that they're midpoints by showing those segments are congruent, and go ahead and connect D to E. So basically what this theorem says is that line segment DE is parallel to BC. So go ahead and put those arrows on them to show that they're parallel. And the length of DE is equal to 1/2 the length of BC. Now keep in mind, whenever we start a new section and it involves parallel lines, then all of those theorems that we studied a while ago come into play. For example, when two parallel lines are cut by a transversal, corresponding angles are congruent. So we'd have pairs of corresponding angles that were congruent here. So now let's take a look at a couple of examples. In example 1, it says in triangle ABC, points D, E, and F are midpoints. So D is a midpoint, E is a midpoint, and F is a midpoint. So I'm just going to mark all of these segments congruent because remember that by definition of a midpoint, we know that it's a point that divides a segment into two congruent segments. So we would know all those segments are congruent to each other. Okay. The first question, we want to know this midsegment FD, it's parallel to what side? And it's going to be parallel to line segment AC. It's down here. Part B says line segment EF, so let's choose a different color. EF would be parallel to BC. And finally, for the third question here, it says line segment AB. This whole side, that's going to be parallel to this midsegment from E to D. And it's okay if you named it DE as well. Just don't forget to put the line segment symbol above it. All right, in the next question, now we're getting into numerical answers, so you have to solve for missing length. It says if line segment FD is equal to 8, that's this segment right here, then AC, this whole side, would be equal to 16. And that's because FD is the midsegment. FD is equal to 1/2 of AC. And since we know that FD is equal to 8, and that's half of AC, all we need to do is take a multiply by 2 to get AC is equal to 16. Okay, in part E, over here on the left, it says if BC, this whole side of the triangle equals 32, that's really a 3, then EF would be equal to what value? Well, EF, that's the midsegment, that's equal to half of the third side. So EF is equal to half of BC. So EF would simply be 1/2 of 32, or 16. So So EF equals 16, because 16 times 2 is 32. Right. And the last question, we're not looking for numerical answers. We're just looking to answer the question, line segment FD is congruent to what other two line segments? Since FD is equal to half of AC, right down here, and AE is also equal to half of AC. AE would be equal to 8, EC would be equal to 8, making FD congruent to line segment AE and line segment EC. Again, because E is the midpoint of this side, these two segments, AE and EC, are congruent, so they're equal to half of this whole side, and FD is equal to half of that whole side as well. In our second example, we are given triangle JKL, where M, N, and O are midpoints of the sides. So we would be able to say that ML is congruent to JM, JN congruent to NK, and OK would be congruent to LO. So what we have here are three mid-segments. So in part A, where it says if MN equals 3x plus 8, and LK equals 2x plus 24, we have to find the length of line segment MN. So we need to be careful that we don't just stop when we find the value of x. So recall from the midsegment theorem that MN, our midsegment, is equal to 1/2 the third side. So it's equal to 1/2 of LK. Or another way of putting this is if you doubled or did 2 times MN, it would also equal LK. So you can set it up either way. You'll get the same answer. So MN is equal to 3x plus 8. And I'm going to go ahead and use this first way. We'll take 1/2 of line segment LK, 2x plus 24. When I distribute the 1/2, it's going to leave us with 3x plus 8 equals x plus 12. Because half of 2x is 1x, half of 24 is 12. So continue to solve for x, subtract x from both sides, and that leaves us with 2x plus 8 is equal to 12. Subtract 8 from both sides, we get 2x equals 4, or x equals 2. But remember, we want to find the length of MN. So take 2 and plug it into here for x. So we're going to do 3 times 2 plus 8, or 6 plus 8, and we find out that MN is equal to 14. Okay, so recall though, again, there are two different ways to set it up. If you're in a spot where distributing the 1/2 would create some crazy fractions, then try setting it up this way. So double the midsegment and set it equal to the third side. All right, in our last example, part B, it says if MO equals 3y minus 5, and JK, that's this side, equals 4y plus 2, we have to solve for JN. So again, we're not going to stop when we find the value of y. We have to follow it through and find the length of JN. So again, the relationship is that MO, the midsegment, is equal to half the third side. So it's equal to half of JK. So 3y minus 5 equals 1/2 of 4y plus 2. 3y minus 5 is equal to 2y, because that's distributing the 1/2, plus 1. Half of 2 is positive 1. Subtract 2y from both sides, so you get y minus 5 equals 1. And that gives us y is equal to 6. Okay, we still have to find the length of JN. So JN is this little piece right here. And it's going to be congruent to MO. So JN and MO have the same length. So let's take and plug in 6 for y into line segment MO. So we need to do 3 times 6 minus 5, or 18 minus 5. And I wrote 15, so let's fix that. 18 minus 5, which gives me 13. JN is equal to 13. And again, I can tell that these two segments are congruent because MO is equal to half of this third side, JN is also equal to half of that third side. Okay, good luck on the CYU and your homework. Please ask if you have any questions or need some help.